Okay, hello. So we're going to look at limits in this video, and I want to do an intuitive approach to limits. So nothing rigorous, nothing formal. This is just to get you thinking, and this is a great way to think about limits when doing problems. So this is an easy way to work with limits and to deal with them. Okay. Once you have the basics down and the intuitive idea, then you can get into the more formal definition of limits and the more difficult definitions for limits. Okay. So, but before we start, I just want to say two things, and these are very important to know. First, limits mean approaching or getting very close to a number, okay? But it does not equal the number, okay? So that's very important. So with limits, it never equals the number. Even though you'll see an equal sign, it does not equal the number. It just means getting very close to the number, okay? And then we'll look at two-sided and one-sided limits, and we'll look at the does not exist case, because limits sometimes actually do not exist. Okay, so what we'll do is we'll start with a nice example. And I'm going to have a function f of x, which is equal to x squared minus x plus 1. And what I want to do, I haven't mentioned, other than in the beginning, I haven't mentioned the word limit yet. But I did mention, well, I guess we did say limits, but what we're going to do is we're not going to mention limit in this problem. We're just going to say this question. We're going to answer this question. Ready? So what is, or let me rephrase that. So remember, limits we are not equal to, we're getting close to. So I should say this. So ready? So what does f of x get close to? Is it 2 or 2? One of those. What does f of x get close to as x gets close to? And we'll just pick a number here, and we'll pick 2. Okay. So that's a fair question. What does f of x get close to as x gets close to 2? And you might be asking, okay, what do I mean by close to? And so non-formal, so non-rigorously, what I mean is numbers close to 2, but not equal to 2. Okay, so what's a number close to 2? 0, 1, 1.5, 1.9, etc. You also have numbers on the other side of 2, like 3, 2.5, etc. So if you draw a number line, you put 2 here, you have 1, 1.5, 1.9, etc. And you also have 3, 2.5, 2.01, etc. So as you can see, these numbers 1.9 and 2.01 are pretty dang close to our number 2. Okay? So what I want to answer is, well, what does f of x get close to? So how do we figure that out? Well, we just plug in. So f of 1 is equal to what? F of 1.5 is equal to what? F of 1.9 is equal to what? Okay? And we can check the other side. So f of 3, f of 2.5, and f of 2.01. What are these equal to? And do I have any of these answers? Well, f of 1 is 1. F of 1.5 is 1.75. You would just plug this into a calculator, right? You're just plugging in 1.9 into this function, Okay, so f of 1.9 is 2.71. F of 3 is 7. Look at that. It's like from this, can you tell what f of, can you answer my question? What does f get close to? It's not very clear. It looks like over here the numbers are getting larger, and then over here the number's very large. So did they keep growing? Or did they stop, and then over here they're going to get smaller and approach some number? We'll see. F of 2.5 is 4.75. So as you can see, it's getting smaller, right? So it went from 7 to 4.25 as x got closer to 2. And then f of 2.01 is 3.03. And you can keep going, and I hope you notice that the closest values to 2, we have these two numbers, 2.71 and 3.03. So what would you say? I would say that my function gets close to what? 3. Okay? I would say my function is getting close to 3 as x gets close to 2. Okay, so as my x value, which is this thing, is getting closer and closer to 2, my function, f of that value, f of x, is getting closer to 3. And you can check closer and closer numbers. So it turns out if you did f of 1.999, this is equal to 2.997. And if you check the other side, f of 2.001, this is equal to 3.003. So as you can see, these numbers are very close to, these numbers are very close to 3, as this number gets closer and closer to 2. Okay, so that's a good way to think about limits. Okay, notice did I ever plug in the number 2? Did I ever plug this number in? No. Could I? Yes. In this case, I could. Why? Because this function is defined at 2. But the beautiful thing about limits is the function does not need to be defined at the value you want to approach. And that's very cool. Okay. So I'm going to show an example of that in a little bit. But what I want to do now is get to the notation that we use. This is just the universal notation that everyone uses for limits. No matter where you go in the world, everyone will understand what you mean when you write this down. So let's do it. So our function was x squared minus x plus 1. And we were getting close to what value? So my f of x was x squared minus x plus 1. What value did we get close to? X got close to 2. And what did f of x get close to? F of x got close to 3. So here's how we put this all together. Ready? We write LIM for limit. LIM just means that you're getting very close to. Okay, you're taking a limit. Then I write this notation. So I put x with this arrow. This means x approaches what? What value did x approach? Right here. X got close to 2. So x approaches 2. And then my function goes in here. So whatever my function is goes in here. Like that. So it's the limit of this entire function. And what was this equal to? What did it get close to? It got close to 3. Okay? So the number on this side is the y value, or the function's value. Okay? The number here, I hope you're taking notes on that. The number here is the value that x is getting close to. And the thing here is just your function. So whatever function you're dealing with. Okay, so that's the notation. So in general, this is what it would look like. You have limit as x approaches any number of your function, and that's equal to something. It's equal to L. Please remember that even though I write an equal sign, it doesn't mean the function equals that value. Okay? It just means getting close to. Okay? This is just the way we write it with an equal sign. But believe it or not, we can also write it like this to avoid confusion. So now you see f of x approaches L as x approaches A. So maybe they should have wrote this like that. But we didn't. We just do equal sign for whatever reason. But okay. So that's a very intuitive way to think about limits. I do want to talk about one more thing. One more thing before we move on. What I did up here, plugging in values and getting the function's value for various numbers, that is a great way to get an idea about a limit. But two things. One, it takes time. It's time consuming and it can be messy. And two, it doesn't always work. It actually can throw you off. And I'll show you an example of where you plug in numbers and it looks like it's going to equal something, but it turns out that it's completely wrong. So where was I? Oh yeah, so what I want to do is I want to show you, so what you'll see a lot is when we deal with something like limit as x approaches 2 of x squared minus x plus 1, I can just, like you saw me, I plugged in values close to 2 into my function, right? Like 1.9, etc. Well, I can also just plug in 2 and see what happens. Okay, so for example, if I plug in 2, I get 2 squared minus 2 plus 1, and that's going to be 4 minus 2, which is 2, plus 1, which is 3. And you see that this limit is equal to 3. Now, you can always do this, okay? But one, sometimes you don't get a number out. Sometimes you get undefined. Undefined is 0 over 0, or actually it's just like a number divided by 0. Actually, I'm sorry, it's 0 over 0. So if you get 0 over 0, it's undefined. Believe it or not, a number over 0 is actually defined for limits. Isn't that cool? You can't divide by 0, that's undefined, but with limits, when you divide by 0, that's actually something. So we'll look at that in a second. So always try to just plug in this value into your function. If you do that and a number comes out, then you're done. That's what the limit equals. Now, when I do plug in this number, I am plugging in, even though I wrote a 2 here and a 2 here, they're not really the number 2. They're numbers close to 2. I just write a 2 though, but they're really supposed to be like 1.999. Okay, so their number is very close to 2. Okay, so I don't know how much we want to do in the first video. What did we do? We just kind of gave you an intuitive approach. So that's not too bad. So let's end there. And in the next video, we'll look at another numerical example where we're plugging in numbers, but the limit doesn't exist. And then maybe we'll look at some one-sided and two-sided limits. And then we'll look at infinite limits. And that should be okay. Alright, I'll see you guys next time.